dear students. Welcome to our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now and press the bell icon to get the notification of the upcoming videos. Students, I promise you to complete your syllabus and to solve your all queries which you may kindly drop in the comment box. So dear students, in my last sessions we have discussed about application of trigonometry. Today we continue with circle. Thus and discussed about what is secant and tangent. This is circle. Suppose C is the circle. The secant is the line which is drawn to the circle which intersect the circle at two distinct points. Here PQ is the line, C is the circle, and PQ is the line which intersect the circle C at the point P and Q. This line is called the secant to the circle, and while the tangent is the line which is drawn, suppose C is the circle and drawn to the circle which intersect the circle at one point. Here the L is the line which intersect the circle at the point P. Then L is called the tangent to the circle. Then at a point, at a single point, we can draw a infinite number of tangents. Infinite number of tangents can be drawn. Suppose P is the point to the circles, we can draw infinite number of tangents L1, L2. In this way, we can draw infinite number of tangents to the circles. And suppose C is the circle, and there also infinite number of seconds can be drawn to the circle. Seconds is the line which intersect the circle at two distinct points, while tangent is the line which intersects at a single point. Okay, let us discuss about some properties of tangent. Let us discuss about some properties of tangent. Theorem 1 says, suppose C is the circle, and O is the center of the circle, and AB be the tangent to the circle which intersect the circle at the point P and join OP. Here we have to the theorem 1 says a tangent to a circle is perpendicular to the radius through the point of contact. The tangent to a circle is perpendicular to the radius through the point of contact. Thus theorem 1 says the tangent to a circle is perpendicular to the radius through the circles. Means here given C is the circle, C is the circle with center O and radius R, and a tangent AB which touches at the point AB touches at the point at P, and to prove that OP is perpendicular to AB. Here we have to prove that OP is perpendicular, means the radius is perpendicular to the tangent. Let's keep it here and let us prove the proof. We have to, among this, let us construct, let Q be any point on the tangent and join OQ. Q be any point and join, and it intersect the circle at the point R. Then we know that among all the line segments joining to the point O to a point on AB, the shortest one is perpendicular. From any point to any line, the shortest distance is always perpendicular to the particular line. Here O is the center of the circle and AB is the tangent, the shortest one perpendicular to AB. To prove that OP is perpendicular to AB. It is sufficient to prove that OP. If we prove that OP is the shortest distance from O to the tangent AB, then we can prove that OP is perpendicular to AB, because we know that the perpendicular distance is the shortest distance from a particular point to a line. Then here let Q be any point on AB and join Q be any point on AB, be any point on AB and join OQ, which intersect the circle at R. Here OP is equal to OR because of radii of the circle, because of radius. Then OQ is equal to OR plus RQ, because look at here. Here OQ means OR plus RQ, which imply that OQ is greater than OR, which imply that OQ is greater than OP. This means OP is always less than OQ. Any point on the tangent, Q is any point on the tangent and OP is always less than OQ. This means OP is the shortest distance of AB from the point O, from the center O, which implies that OP is perpendicular to AB. Hence, we prove that OP is perpendicular to AB. Then let us discuss theorem 2. Then theorem 2 says, here a line drawn through the end point of a radius and a perpendicular to it is a tangent. This is the converse of the theorem 1. This is the converse. Suppose this is the circle C and here the line drawn through the end point. Here AB is the tangent which touches the circle at the point P, and O is the center of the circle, and OP is perpendicular to the tangent AB, and here join OQ which touches the circle at the point R, and here we have to prove that AB is the tangent to the circle at a point AB. Here given C is the circle with center O and radius R and APB is perpendicular to OP. OP is the radius and a line APB is perpendicular to OP. Here we have to prove that AB is the tangent to the circle at P. AB is the tangent to the circle at P. Okay. Then let us prove. Let us keep it here and let us prove. Here we have to prove. Then take a point Q on the line AB and which is different from P and join OQ. Then such that here given that Q be any point of line AB and join OQ which intersect the circle at R, and here also given that OP is perpendicular to AB. This means among all line segments which join O to the point on AB which join the line AB, OP is the shortest distance. As OP is perpendicular to AB and OP is the shortest distance, this means OP is always less than OQ, which implies that OQ is greater than OP. This means Q as OQ is greater than OP. This means OQ is not the radius, which implies that Q always lies outside of the circle, which shows that Q always lies outside of the circle. This means AB is the tangent at the point P. Q lies outside the circle, which shows that AB is the tangent to the circle at the point P. B is the tangent to the circle at P. Okay, then look at here. Suppose C is the circle with center O and radius R, and here the conditions given that OP is the radius and the line APB is perpendicular to OP. We have to prove that AB is the tangent to the circle at P. Here let Q be any point of line AB. Then join OQ. As OP is given here, OP is perpendicular to AB. This means OP is the shortest distance from O to the line P, which shows that OP is and Q be any point on the AB. Then here OP is less than OQ. This means OQ is greater than OP, which shows that OQ is Q is the point which is outside the circle. This means AB is the tangent to the circle at P. Okay, then let us discuss the theorem 3. Here let us discuss the theorem 3. Theorem 3. The theorem 3 says that the length of two tangents drawn from any external point to the circle are of equal length. Suppose C is the given circle. And A be any external point, then O is the center of the circle, then AP is the tangent which touches the circle at point P, and AQ is another tangent which touches the circle at the point Q. Here we have to prove that AP is equal to AQ. Length of AP is equal to length of AQ. The length of two tangents drawn from an external point to the circle are of equal length. Here the given condition that C is the circle with center O and radius R, then and AP and AQ are two tangents from an external point A to the circle C. A to the circle C. Then here we have to prove that AP is equal to AQ. Length of AP is equal to length of AQ. Then let us join OP and OQ and AO. Let us join OP, OQ and AO. Let us prove. Keep it here and prove. Join OA, OP and OQ and consider the triangle AOP and triangle AOQ. Consider the triangle AOP and triangle AOQ. Then here, as we know that OP is equal to OQ because they are common radius of the, because they are due to radius of the same circle radius, and OA is the common side. OA is equal to OA common side, and as we know that OP is the radius perpendicular to AP and OQ is perpendicular to AQ, which shows that the angle OPA is equal to the angle OQA right angle. Perpendicular means they are right angle. This means by RHS property, right angle side hypotenuse. Right angle side OA is the common, as this is the perpendicular, this is perpendicular, this is the right angle. This means OA is the hypotenuse, common hypotenuse for the two triangles. Then by the RHS property, right angle hypotenuse and side by RHS property, then by RHS property, these two triangles are congruent. Triangle AOP is congruent with the triangle AOQ. AOP is congruent with the triangle AOQ. This shows that AP is equal to AQ by CPCT, corresponding part of congruent triangles. Then by CPCT, these two sides are equal. AP is equal to AQ, which we have to prove. Okay. Then discussed about theorem 4. The theorem 4 says if two tangents are drawn to the from any external points are equal of length, then they subtend equal angles at the center. Then before discussing about theorem 4, let us discuss about some examples. I have already told you, students, always practice variety of questions. Only knowing theory is not sufficient. Let us discuss about some examples. Here the question says a tangent, suppose O be the circle, C be the circle, and O is the center of the circle, and PQ is the tangent to the circle, and here OP is given of 5 centimeter and Q be the point exterior point of the circle, and OQ is of length 13 centimeter. Then here we have to find out the length of PQ. Here we have to find out the length of PQ. As we know that the radius is perpendicular to the tangents, OP is perpendicular to PQ. Here OPQ is a right angle triangle, triangle where P is the right angle. Then by Pythagoras theorem, as we know that H square is equal to P square plus B square. This means OQ square is equal to OP square plus PQ square, which implies that PQ is equal to OQ square minus OP square square root, which is equal to 13 square minus 5 square square root, 144 minus 25 square root, which is 169 minus 25 square root, which is 144 square root, which is equal to 12 centimeter. Here the length of PQ is equal to 12 centimeter. Then let us discuss some properties of tangents. A point common to a tangent and a circle is called the point of contact. Suppose this is the circle C and the point which is and AB is the tangent to the circle and O is the center. The common point between the circle and the tangent is the point of contact P. And the circle may have two parallel tangents. Suppose this is a circle. This circle may have two parallel tangents. Suppose this is a tangent and this is another tangent. Suppose this is AB and this is XY. AB parallel to XY. Only two tangents can be parallel to each other to any circle. Then another property says the tangent to a circle intersect it in one point. A tangent always intersects the circle at a single point. When it intersects the circle at 2 points, it cannot be a tangent. It should be a secant to the circle. Then the fourth property says a line intersecting the circle at 2 points is called a secant. The angle between the tangent at a point on the circle and the radius through the point is always right angle. Suppose this is the circle C and this is the tangent which touch the circle at the point P and O be the center. Always OP is perpendicular. This is always a right angle. Then let us discuss some more examples. Let us discuss some more examples. Here some examples 2 says, here example 2 says, suppose P is the exterior point, suppose C is the circle and P is any exterior point and O is the center of the circle, then distance between O and P is 13 centimeter given and the length of the tangent is also given. This is 12 centimeter. It touches the circle at the point T and PT length of the tangent is given 12 centimeter. Here we have to find out radius of the circles. Means we have to find out OT. Here OP is given 13 centimeter and length of the tangent PT is given 12 centimeter. Here we have to find out OT. As we know that OT is perpendicular to PT because we know that radius is always perpendicular to the tangents at the point where the tangent touches the circle. Then OT is perpendicular to PT. This means PTO is a right angle triangle. Is a right angle triangle where T is the right angle. This shows that OP is the hypotenuse. Then by Pythagoras theorem, then by the Pythagoras theorem, as we know that h square is equal to p square plus b square. Here OP square is equal to PT square plus OT square. This means we have to find out here the length of OT. OT is equal to OP square minus PT square root, which is equal to 13 square minus 12 square root, which is equal to 169 minus 144 square root, which is equal 25 square root means 5 centimeter. Here the length of the radius is found 5 centimeter. Then thank you students. Today this much. In my next sessions we will continue with this. Thank you students.